Welcome to our channel. Today, we're diving into one of the most debated topics in history, the moon landing. Now, I love a good conspiracy theory as much as the next cosmic enthusiast, but some claims are simply out of this world, literally. The fact is, on July 20th, 1969, humans set foot on the moon, a monumental achievement for science and engineering. Yet some still cling to the idea that it was all a hoax, a grand production staged in a Hollywood studio. So, let's put on our critical thinking caps, grab our spacesuits, and journey through the cosmos of evidence to debunk some of the most popular moon landing myths. Buckle up, space cadets, because as we explore these claims, we'll learn not only about the moon landing itself, but also about the fascinating science that makes it all possible. First up, let's tackle the mother of all moon landing myths, the idea that the whole thing was faked. Now I get it, the universe is full of mysteries, but this isn't one of them. To think that NASA pulled off a hoax of this magnitude back in the 1960s requires a level of disbelief in human ingenuity that's, frankly, astronomical. Let's talk technology. In the 1960s we were just entering the computer age. The computers used for the Apollo missions were less powerful than your smartphone. Faking a moon landing would have required CGI technology far beyond anything available at the time. And the logistics? It would have taken a cast of thousands to keep such a massive secret. Imagine trying to get that many people to stay quiet. It's far more likely that we actually went to the moon than successfully faked it and kept it under wraps for over 50 years. Think about the sheer scale of the Apollo program. Over 400,000 people worked on it. Scientists, engineers, technicians, these were some of the brightest minds on the planet, all focused on one goal, getting humans to the moon. The Saturn V rocket, the most powerful ever built, stands as a testament to their efforts. This engineering marvel, taller than the Statue of Liberty, generated enough thrust to escape Earth's gravity and propel the Apollo spacecraft towards the moon. The evidence is overwhelming. We have thousands of photographs, hours of video footage, and lunar samples analyzed by independent scientists worldwide. The moon landing wasn't just a moment in history, it was a triumph of human collaboration, ingenuity, and the relentless pursuit of scientific exploration. Ah, the infamous waving flag. This is a classic example of how a lack of context can lead to wild speculation. Now let's be clear, there's no air on the moon, so a flag can't flap in the wind like it does here on Earth. However, the flag wasn't just dangling from a pole, it was designed with a telescoping arm to make it fly proudly. This arm, along with the wrinkles from being folded during the journey, gave the flag its wave-like appearance. Think about it. If NASA were really trying to fake the moon landing, wouldn't they have accounted for such a basic detail? They were trying to convince the world of a monumental achievement, not win an award for flag design. The flag appears to wave because of the way it was mounted and the properties of the fabric in a vacuum. When the astronauts planted the flagpole, they rotated it back and forth to dig into the lunar soil. This movement, combined with the lack of air resistance, caused the flag to ripple and appear to wave in the breeze. But here's the kicker, the flag doesn't actually wave on its own. Once the astronauts stopped moving it, it remained in a relatively static position, as it should in an environment with no atmosphere. This myth is easily debunked by understanding the physics of motion and the design of the flag itself. It's a testament to how a simple misunderstanding can snowball into a full-blown conspiracy theory. Now this myth always makes me chuckle. It's like complaining that you can't see any stars when the sun's out. The lunar surface, bathed in sunlight, is incredibly bright, much brighter than we experience here on Earth. Cameras, even those fancy ones used by NASA, have limitations. To capture a clear image of the astronauts and the lunar landscape, the cameras needed a fast shutter speed and a narrow aperture, which limited the amount of light entering the lens. Think of it like taking a picture of a friend standing in front of a setting sun. Your friend might be properly exposed, but the background, including the stars, will appear dark. It's all about balancing the exposure to capture the subject of the photo. The same principle applies to the moon landing photos. The priority was to capture the astronauts and the lunar surface in detail, not the faint light of distant stars. It's also worth noting that the astronauts landed on the moon during the lunar day, when the sun was shining brightly. This further illuminated the lunar surface, making the stars even more difficult to see. So, The absence of stars in the photos isn't evidence of a hoax. It's a simple matter of photography and the limitations of capturing images in a high-contrast environment. The mysteries of light and shadow. This myth claims that the shadows in the moon landing photos are inconsistent, suggesting they were artificially created in a studio. However, this misunderstanding stems from how we perceive light and shadow here on Earth. On Earth, we're used to a single dominant light source, the sun. But on the moon, things are a bit different. You have the sun, yes, but you also have light reflecting off the lunar surface itself. This creates a more diffuse and multi-directional light source, leading to shadows that might appear off to our Earth-trained eyes. Imagine standing in a room with multiple lamps. Your shadow will change shape and direction depending on the position and intensity of each light source. The same principle applies to the moon, where the uneven terrain further complicates the way shadows are cast. The shadows in the moon landing photos are entirely consistent with what we'd expect in a lunar environment. They're not perfectly parallel because the lunar surface isn't perfectly flat, and they're affected by multiple light sources. This myth highlights how our Earth-centric perspective can sometimes lead us to misinterpret what we see. By understanding the unique lighting conditions on the moon, we can appreciate the authenticity of the shadows captured in the Apollo mission photos. Now this myth touches on a genuine concern: the Van Allen radiation belts. These belts, discovered in 1958, are donut-shaped regions of charged particles trapped by Earth's magnetic field. They pose a radiation hazard to spacecraft and astronauts passing through them. However, the Apollo missions were designed with this hazard in mind. The spacecraft trajectories were carefully calculated to minimize the amount of time spent in the belts. The Apollo spacecraft also had radiation shielding to protect the astronauts. Think of it like driving through a rainstorm. If you drive slowly and carefully, you're less likely to hydroplane. Similarly, the Apollo missions minimized their exposure to the Van Allen belts by passing through them quickly and at specific angles. Moreover, the Van Allen belts are not a solid wall of radiation. The radiation levels fluctuate, and the Apollo missions coincided with periods of lower radiation intensity. The astronauts did receive a dose of radiation during their missions, but it was well within safe limits. In fact, they received less radiation than what's considered acceptable for workers in certain professions here on Earth. The Van Allen belts are a real phenomenon, but they were not an insurmountable obstacle for the Apollo missions. The risks were understood, and precautions were taken to ensure the safety of the astronauts. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content. Leave a comment below with any other myths you'd like us to debunk. Remember, it's okay to be skeptical and question what we see. It's that same spirit of curiosity that led us to the moon in the first place. But as we explore the cosmos, let's ground our curiosity in science, logic, and a healthy dose of critical thinking. Keep looking up, keep asking questions, and never stop exploring the universe around us.